If you need to pass GED math, know that if you can get more GED geometry questions right on your test, it's going to help your score. And I put a lot of important information in this video to help you do better with geometry questions on the test. And know that if you're coming here from part 1 and you've already seen part 1, I really appreciate you coming back to watch part 2. And if you're just starting out with part 2 and you haven't seen part 1 yet, know that I really appreciate you being here. I'll put a link to part 1 down below in the description if you want to watch that as well. And know that I wanted to just do this whole GED geometry study guide in just one big long video and put everything in one place for you, but I had some unforeseen difficulties, mainly my laptop running out of space. Now I'm thinking I'm going to have to do this in 3 parts, so I am going to add a 3rd part and add that to YouTube at some point. So I'll let you get started now. I'm wishing you the best of luck with your test prep. What's the measure of the missing angle of the trapezoid? Is it A, B, C, D, or E? So now's your chance, if you'd like to pause the video, try to figure this out. And if you get stuck, don't worry about it because we're just going to go over the answer. Okay, so for this question here, what we want to do is set up an equation here, and we're trying to find this missing side here. And we know that a trapezoid is a 4-sided plane figure. And we know that for 4-sided plane figures, the internal angles are going to add up to be 360 degrees. So from that fact, we can write the following equation. We can say that 105 plus 75 plus 72 plus x equals 180. And the reason that I'm putting x here is to represent the unknown side. Now you could have put a, b, c, d, z, y, whatever you wanted here instead of x. I'm just putting an x here just because that's just what I picked. But the point here is that this is going to add up to be 360, not 180. Okay, forget that I said 180. I, just had my brain went out to lunch for a second there, but it is 360. So the missing angle here, to find it, we want to do 105 plus 75 plus 72 plus x and set it equal to 360. If this was a triangle, you would set it equal to 180 because the 3 internal angles of a triangle add up to 180. But for a 4-sided plane figure, all the internal angles add up to 360 degrees. So let me add this up in my calculator. 105 plus 75 plus 72, and I get 252 plus x equals 180. No, I'm just kidding. It's actually 360. So remember again that the internal angles of a trapezoid add up to 360. And now what I'm going to do is I'm going to subtract 252 from both sides. Now the reason I'm doing this is because I've got positive 252. If I subtract 252 from that, these will cancel out, leaving me with just x. And whatever I do to one side, I also have to do it to the other side as well. And so if I do that, I'll see that the answer is 108 degrees. So x equals 108 degrees. C is correct. So for this question, I'm going to issue both a Champions Challenge and an Extreme Champions Challenge. And it's up to you to decide which one you want to try, or you can try both of them. And the Champions Challenge is just simply to solve the question. You can use your calculator, you can do the calculations by hand, however you want to do it. And the Extreme Champions Challenge is to try to answer this question without doing any calculations. So again, the Champions Challenge is just to solve the question, and the Extreme Champions Challenge is to try to solve this question, but you can't do any calculations. So if you take the Extreme Champions Challenge, you have to just look at the answer choices, look at the picture, think about what you know about 4-sided plane figures and parallelograms, and try to just reason your way through it and get the answer, but you can't do any calculations. So whichever one you want to try, it's totally up to you. Again, this is a challenging question, so if you struggle with this, absolutely no worries, because we're just going to go over the answer. Okay, so let's talk about this question. So let me first show you how you would do this doing a calculation. And so we know that for a parallelogram, opposite angles are going to be equal. So if this angle right here is 85, we know that the angle that is opposite of it, which should be angle B, is also going to be 85. And we know that C and A, since they're opposite, we know that they're going to be equal, but we don't know what they are yet. So we can set up this equation. So we can do 85 plus 85 plus x equals 360, because for all 4-sided plane figures, including parallelograms, the internal angles must add up to be 360. So we've got 85 plus 85 for these two angles right here, And we don't know what angle C is, so I just call it X. And we don't know what angle A is, but we know that it's the same as angle C, so I also call that X. And we know that this is equal to 360 degrees. So 85 plus 85 is 170, and X plus X is 2X. So we would have 170 plus 2X equals 360. So the way to move forward now would be to subtract 170. And we do that. We do subtracting 170. We see that 2X equals 190. So now what we're going to do is we are going to divide by 2 on both sides to get the X. And when we do that, we see that X equals 95. So what we now know is that C and A both equal 95 degrees. So the correct answer here would be E. Extreme Champions Challenge would be to do all this without a calculator or doing any kind of calculation. So how would you do that? So let me get all this out of the way here. Well, actually, if we really understand the concepts here, we can do it because we know right off the bat that 85, this angle here that's 85 is opposite angle B. So we would know that B is 85. Okay, so without doing any calculations, right off the bat, we could eliminate A because we know that B can't be 105, and we could eliminate C because we know that B can't be 115. How do we know that? Well, we know that because this angle right here, we're told that it's 85, so we know that B has to be 85. So without doing any calculations, we can rule out A and C. So what next? How could we get the answer from here? Well, we know that angle A and angle C, we know that they are equal. So we now have to find an answer choice that where both A and C are equal. Okay, because angle A and C are opposite from each other, that means that they're going to be equal in measure for a parallelogram. So if I look at B, I see that A is 85 and C is 95. That can't be the correct answer because they have to both be equal. And I look at D, I see that A is 100 and I see that C is 113. Well, this can't be right because for a parallelogram, the opposite angles are equal. So I look at A and I see that that A is 95, or I look at answer choice E, I see A is 95, and I see that C is 95. So I know that these are equal, so by process of elimination, I would see that E is the correct answer. Okay, so that would be the Extreme Champions Challenge. If you were able to get E without doing any calculations, great work. And either way, whether you got this right, whether you got this wrong, great job just for trying this. This is not an easy question, and hopefully this was a learning experience. And right now we're going to shift gears and talk about volume and surface area and how to do these calculations. And on a lot of the practice test examples that I've seen, they usually have at least one volume or surface area question, sometimes multiple. And if you've already taken the GED math section, please let me know down below in the comments if you got a volume or surface area question, or if you've taken practice tests and you've seen these questions, just let me know down below because in my opinion, these are quite common on the GED test. Now, I should say that there are 3 different versions of the test and the version you get is going to be random. So there's no guarantee exactly which questions you're going to get on the test, but it's usually a safe bet that you'll get at least one of these types of questions. Again, that's not a guarantee, but these do come up quite commonly. Volume and surface area of a rectangular prism is what we're going to start with here. So on screen, I have a colorful rectangular prism. And I don't want to overload you with all the details. I mainly kind of want to focus on what is going to be most helpful for getting questions right on your test. But I do want to start by saying that a rectangular prism has 6 faces, 12 edges, and 8 vertices. So the faces are kind of the flat portions of this rectangular prism. These are the faces, and I'm not going to draw all 6. It's kind of hard to show you without picking this cube up and rotating it around. It'd be easier to show you all 6 of the faces, but there are 6 of them. And there are 12 edges, and the edges are just the lines, right? So edge is just a fancier way of saying line. So if we count up all the lines here, we would get 12. And for the sake of time, I'm not going to count them all up. I'm just showing you a couple here. But the edges are just the lines of the figure. And the vertices are just the points where the lines come together, right? So a vertex in math is a point where 2 or more lines come together. So here's an example of one, and they basically are the corners of this figure, right? So here's one, here's one, here's one, and again, for the sake of time, I'm not going to mark every single one, but there are 8 of them. Now, a cube is a special type of rectangular prism, and for a cube, all of the edges are going to be the same length. So we can write a formula for volume of a cube. So I'm going to put V and I'm going to put a little c here, and this stands for volume of a cube. So the volume of a cube, the formula you can use is edge cubed. So you can take the length of one edge and you can cube it. All right. In other words, you would do edge times edge times edge. So that's how you would find the volume of a cube. And this formula is not on the formula sheet, but I just want to kind of put this here just to cover all of our bases. And again, these two formulas right here, you don't have to memorize these. These will be given to you on the official formula sheet. So we have the example question on screen, and we have the formula right here that you'll need. And again, on the test, you'll want to go to the formula sheet and you'll want to look up this formula. But I just put it here to save time since we're just practicing. And one more thing I want to note here, just ignore that this says 90. I took this practice problem out of a practice problem collection that I put together several years ago now. So that's why it says 90, because it was the 90th problem in that collection. But don't worry about that number. And let me give you a chance now to pause this video, try this out, and whenever you're ready, we'll go over the answer. Okay, hopefully you had a chance to try this. If you wanted to, let's go over it now. So the volume formula is length times width times height. Now in this question here, 9 is the length, 5 is the width, and 10 is the height. So I'm going to do 9 times 10, 9 times 5 times 10. And the order doesn't matter as long as you multiply these three numbers together. So if you did 10 times 5 times 9 or 9 times 10 times 5, whatever order you put these three numbers in, you're still going to get the same answer. So if you forget which one here is the length and which is the width, it doesn't really matter as long as you know to multiply these three numbers together. You're still going to get the same answer. And B is correct here, 450. So here's a different variation of a volume of a rectangular prism example. And this one says, if the volume of this rectangular prism is 2,340 cubic meters, what is the height? And again, don't worry about this 139 here. And so let me give you a chance now to pause the video, try to figure this out. And whenever you're ready, we'll go over the answer. So in this case here, we know that the volume is 2,340, but this time we don't know what the height is. So I can still use this formula, volume equals length times width times height. And in this case, for V, I'm going to plug in 2,340 because I know that that's the volume. So I'm going to, again, take this formula up here and I'm going to write 2,340. And I'm going to say that this is equal to 13 times 6. So I have it equal to 13 times 6 times H. And the name of the game here is to figure out what H is. So we want to get H by itself on one side of our equation here. So the first thing that I'm going to do is I'm going to do 13 times 6. And 13 times 6 is 78. So I'm going to rewrite this here. And when you do your work, you don't necessarily have to write out every single step like this. I'm just doing this. I'm writing out every single step for instructional purposes. So 13 times 6 is 78. So I have 2,340 equals 78H. So how do I get this H? Well, since I have 78H, that's 78 times H. So I want to do the opposite of times, which is division. So what I want to do is divide by 78. And if I divide 78 by 78, they're going to cancel out, leaving me with just H. But whatever I do to one side, I also have to do it to the other side. So I'm going to come over here and I'm going to do 2,340 divided by 78. And when we plug that in our calculator, we see that A is the correct answer. And if you want to test if this is right, what you can do is you can come back up here and you can do volume equals length times width. So you could do volume equals 13 times 6 times 30, and you could plug that into your calculator, and it should give you 2,340. Okay, let's look at surface area now of a rectangular prism. So here's the question. It says calculate the surface area of the rectangular prism below. Don't worry about the units, and I have the formula that you'll need up on the screen. So let me give you a chance now to pause the video, try this out, and whenever you're ready, we'll go over the answer. Okay, so in this case here, we're going to use this formula for surface area. And whenever you see a question like this, you just want to take your time and just triple check that you're putting the numbers into the formula the correct way. As long as you put the numbers in the right way and put them in your calculator the right way, you're going to get the correct answer. It's just a matter of just being patient and just maybe double or triple check, quadruple check even that you put the numbers in the right way. That is really something that you should do with all formulas on the test, but especially long formulas like this. So 3 is our length. So 3 equals L, and 2 is our width. So 2 equals W, and 4 equals H. So basically, we just want to plug all of these numbers into this formula. So let me write it out, and then I'll show you what it should look like. So we should have this. We should have 2 times 3 times 2 plus 2 times 3 times 4 plus 2 times 2 times 4. And again, this is just a matter of just being careful to make sure that we put the numbers into the formula the right way. So if we put all this into our calculator, we'll see that 52 is the correct answer. So D is the right answer here. You might be wondering why you're looking at a can of soup on the screen right now, and hopefully shortly it'll be more obvious. So let's talk now about cylinders. And there's two main things that you should know about cylinders. So the first is what a cylinder looks like, and you can remember what a cylinder is because it looks like a can of soup. And it kind of sounds like it too. Cylinder, soup, cylinder, soup, cylinder, soup. Okay, maybe that's kind of a dumb way of remembering it, but hopefully you get the point. So you'll want to know what a cylinder looks like, and I have a picture of one up on the screen here. And you'll also want to know how to use the formulas. So let's get into an example right now. So I almost didn't include this question in this video because I think it's a little bit harder than what I would have liked it to be just to demonstrate how to do a basic calculation of the volume of a cylinder. But anyway, I decided to put it in here anyway. So the question is, what is the volume of a cylinder with a diameter of 10 inches and a height of 5.5 feet? So let me give you a chance to try this out. And whenever you're ready, just unpause the video and we'll go over it. Okay, so whether you got this right or wrong, it doesn't matter right now because we're just practicing. If you got this right, great job. If you struggled with this question, great job just for trying. All we care about right now is the learning. And so we'll go over the answer now and how to do this. And the first twist to this question is that the question gives us the diameter. And if we look at the formula for the volume of a cylinder, the formula has the radius. So the first thing that we're going to want to do is take this diameter and we're going to want to cut it in half. So if the diameter is 10, the radius is 5. So that's the first little trap here. So if you saw that, you needed to convert this diameter to radius first. Really great job. If you didn't see that, don't worry about it. Now, the next thing here is that what we have to see is that the height is in feet, but all of the answers are in inches. So before we do our calculation, we want to take this 5.5 feet and we want to convert it to inches. So you might be wondering, how do we do that? Well, let me show you. The fast way to do it is just to remember to multiply 5.5 by 12. And if you multiply it by 12, that is going to put you right into inches. But let me just briefly explain why that makes sense. So 1 foot is equal to 12 inches. So the reason why I want to multiply by 12 is because when I set it up this way, 5.5 feet times 12 inches divided by 1 foot, the units will cancel out and it leaves me with an answer in inches. So we want to do 5.5 times 12 and 5.5 times 12. Let me do that in my calculator, and that is 66. So 5.5 feet is 66 inches. So now that we have this in inches, now we can plug and chug here. So we'll come up to the formula and we see that fortunately pi is left in all the answer choices, so we don't actually have to multiply by 3.14 here. So we have volume equals pi times r squared, and my r squared is 5. So 5 squared is 25. So I'm just going to put 25 here. So we have pi times 25 times h, and our h is 66. So if I do 25 times 66, I'll see that the answer is 1,650 pi. So if you got this right, really great job. If not, great job for trying. There were two different twists here. Like I said, I feel like this question is maybe a little bit more complicated than a basic volume of a cylinder question would be, but I figured I'd just put it in here because why not? So now we're going to do surface area of a cylinder, and the question is, what is the surface area of a cylinder with a radius of 6 centimeters and a height of 20 centimeters? So let me give you a chance now to pause the video, try to figure this out, and as always, whenever you're ready, we'll just go over the answer. Okay, so this question here, the key to getting this right is first of all picking the right formula, which we see on screen right here. And second of all, just taking your time and just plugging the numbers in and putting the calculation into your calculator, and that'll give you the answer. And this should go without saying, but this is just a reminder to just always double check that you put the numbers into the formulas the right way, and also double check that you put the numbers in your calculator the right way. I mean, if you're If you have time to, I would even do the calculations twice, or at least just look at your calculator screen and make sure that you put it in the correct way. And I know it sounds like common sense, but I just don't want you to lose any points on your test just for a calculator error or just for putting something into a formula wrong. So that's just why I'm taking a minute here to kind of harp on this here. But anyway, this is how we'll have this set up. We have 2 pi rh, so it should be 2 pi 6 times 20 plus 2 pi 6 squared. And so if we put this in our calculators, we will get 240 pi plus 72 pi. Now the key here is to just add 240 and 72 and bring the pi along for the ride. So if I do that in my calculator, I get 312, and I just bring the pi along for the ride. Now over here in all of the answer choices, we see that we have pi left in the answer choices, which makes our life easier. If we didn't see this pi in the answer choices, you would just do 312 times 3.14. But in this case, it's simple to proceed because we don't have to actually multiply by 3.14. So 312 is the answer here. So on screen right now, I'm showing an example of a pyramid, and pyramids are on TV and in movies quite a bit. I mean, it seems like there's all kinds of documentaries about Egypt and stuff like that on TV all the time where they show pyramids. And I actually Googled a list of movies that have pyramids in them, and there's quite a few movies, especially a lot of popular ones like The Mummy and The Mummy Returns. And I've seen Alien vs. Predator, but it's been many years since I've seen that. And there's all kinds of examples. But anyway, so on screen we see a geometric pyramid, and there are a few things to note about geometric pyramids. And basically, there are 4 triangular faces, and these 4 triangular faces meet at a vertex. And we call this vertex the apex because it's the highest vertex on the figure. And the apex is also opposite of the base down here. Now, when we look at these formulas, first of all, note that these formulas will be given to you on the formula sheet. You won't have to memorize them. And they are similar to the other formulas, but there are a couple little nuances here that I want you to be aware of. So first, the B in both the volume and surface area formulas is for the area of the base. And now when we look just at the surface area formula, note that this S is slant height and this P is perimeter of the base. So just remember that. And basically, if you're wondering what the slant height is, if you come up here to the apex and you draw a line coming right down here to the base, simply put, that's what the slant height is. And so the most important thing is, of course, knowing how to use these formulas. So let me get into an example or two now. What is the surface area of a pyramid with a slant height of 10 feet, a base with a perimeter of 20 feet, and a base with an area of 15 feet? And yes, I do see a typo here, but we're just going to roll with it. And basically, let me give you a chance now to pause the video and try to figure this out. And whenever you're ready, we'll go over the answer. Okay, so let's go over this now. So we're going to use the surface area formula. The question is, what numbers are we going to plug in? So we'll start with half times P. So what am I going to plug into the formula for P? Well, we're told that a base with a perimeter of 20 feet. So that is our giveaway that we're going to plug 20 in for P. And now I want to multiply by S. And S stands for slant height, and we're told that it has a slant height of 10 feet. So I'll put times 10 right here. And then to this, we're going to add the area of the base. So we're told a base with an area of 15 feet, so we're just going to add 15 here. Now, you're more than welcome to put this in your calculator if you want to, and if you do that, you'll see that the answer is 115. Okay, so this is a volume calculation for a pyramid, and there's a little twist here to this, and this is more, I'm just throwing this out here just to kind of cover all of our bases, just in case this were to come up on your test that you're not blindsided by it. But here's an example here, and it says if a pyramid has a height of 10 inches and a base edge of length 8 inches, what is the volume of the pyramid? So let's say that this pyramid here has a square base for the purposes of this question, and when I looked in one company's textbook to check what they had to say on this, they claim that every pyramid on the GED test is going to have a square base. Then I looked in a different textbook from a different popular company, and that company claims that the majority of pyramids on your test are going to have rectangular bases. So those are two very contradictory pieces of information, and I honestly couldn't tell you which one is right. But for the purposes of this question here, let's say that this pyramid has a square base. It kind of looks like that in the picture. This does look like a square, so maybe that's a clue here. So now's your chance, if you'd like to pause the video, try to figure this out, and then whenever you're ready, we'll go over the answer. Okay, so as I promised, there is a twist here to this question. It's a slight twist. And the twist is that we need to plug in the area of the base into the formula here. Now, the question doesn't give you the area of the base. The question just tells you a base edge of length 8 inches. So you might be wondering, what in the world does that mean? Well, if we look at the figure here on screen, what we should see is that the base is a square. So this pyramid has a square base. So what we need to do to get the area of the base is just do a calculation for the area of a square. So a square has 4 sides that are equal in length. And the area of a square, the way we find that is we do side squared, right? We take one side and we square it. In other words, we're going to do side times side. So if you want to think of it as 8 squared or think of it as 8 times 8, 2 ways of thinking of the same thing. Either way, we will see that 64 is the area of the base. So here's the twist here again. We need to plug the area of the base into the formula. And since this pyramid has a square base, we need to calculate the area of that square, which is 8 times 8 or 64. So that's what I'm going to plug into the formula here for the area of the base. And the height is just 10 inches, so I'm just going to plug 10 in here. So when we do the calculation, we're going to do volume of the pyramid equals 1/3 times the area of the base, which is 64, times the height, and the height is going to be 10. So when all is said and done, we're going to get something like this. We're going to get 213.333 and a bunch of threes. And I don't really care how you round it if you round it. As long as you got something close to this, consider it that you got the right answer. And again, I just wanted to show you this example here, even though it has a little twist, just to kind of cover all of our bases, just in case something like this were to come up. At least you've seen an example like it. So let's now talk about a cone. And we've already talked about cylinders, and cones are kind of like cylinders in some ways, right? So if we look at our cylinder right here, what we'll see is that the cylinder has 2 different circles. It's got a circle at the top and it's got a circle at the bottom. And you can't really see these circles from just looking at this view, but if you could look at the top of this soda can and at the bottom of the soda can, pop can, whatever you want to call it, you would see those 2 circles, right? So a cylinder has 2 circular bases. Now a cone has 1 circular base down here. So a cone is kind of like a cylinder, but it is different. Now, what we could say is that if we took a cone, we could fit a cone inside of a cylinder, but you can't fit the cylinder inside of the cone. All right, so that being said, let's jump into some problem solving. So this next question that I want to go over was written by the GED testing service. This is a question that is in the freely available math practice questions released by the GED testing service. So I'll put a link to this down below. And so it says, an office uses paper drinking cups in the shape of a cone with dimensions as shown. To the nearest tenth of a cubic inch, what is the volume of each drinking cup? So let me give you a chance now to pause the video, try to figure this out. And whenever you're ready, we'll go over the answer. Okay, so when I look at this question here, the first thing that I note is that what they're showing here is the diameter of the circular portion of this cone here. And the formula for volume calls for the radius. So the first thing that we're going to have to do is take this 2 3/4 inch and we're going to have to cut this in half to get the radius. So 3/4 as a fraction is the same as 0.75. So 2 3/4 is the same as 2.75. So I'm going to cut that in half. I'm going to do 2.75 divided by 2, and that equals 1.375. Okay, so this is going to be my radius, 1.375. So that's the first thing that I note here. And now I'm going to come up here into my formula. And what I also see here is that they don't have pi left hanging out in any of the answer choices. So we're actually going to have to use 3.14. And we're going to plug 3.14 into this formula in place of pi. Right, so we have 1 over 3 times 3.14 times 1.375 squared times 4. And if we do the math here in our calculator, we're going to get a number that is about 7.9. And the correct answer here, rounded to the nearest tenth, is B, 7.9. So now let's look at an example of the surface area of a cone. And one thing I want to point out is the difference between the height and the slant height. So if we look at a cone here, like this image right here, this line here would be our height, and the slant height is actually on the side. So let me give you a chance now to pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. Okay, so basically what we want to do here in our formula is just plug the numbers in. We know that the radius is 6, so I'm going to plug 6 in for r, and our slant height is 12, so I'm going to plug 12 in here for the slant height. And we see that both of our terms have pi in them, so one thing that I can do, and you don't have to do it this way, but I can actually pull that pi out since there's a pi in both terms. So I can write it like this. I can write 6 times 12 plus radius squared, which is 6 squared. 6 squared is 36. So then doing this in your calculator, you get 108 pi. So if you left your answer like this, that's perfectly fine. I actually didn't specify, but if you wanted to multiply it out, you do 108 times 3.14, which my calculator gives me 339.12. So I actually should have specified this beforehand, but if you got 108 pi and left it like that, that's perfectly fine. If you did 339.12, that's perfectly fine too. And what you also could have done instead of doing this little trick here where you pull the pi outside is you could have just gone right up here and you could have done 3.14 times 6 times 12 plus 3.14 times 6 squared and plug that all in your calculator, and that would also be a fine way to get the answer. Okay, so on screen we see a sphere, and there are two formulas on the formula sheet that you'll want to be familiar with. You won't have to memorize these like always, but these are formulas you'll want to be familiar with. And there isn't a whole lot to really say about spheres here, other than just to know what they look like and to know how to use the formulas. So let's jump right in here with a calculation here. And this question says, calculate the volume of a sphere with a radius of 3 meters. So let me give you a chance now to pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. Okay, so let's talk about this question here. And so this is hopefully pretty straightforward. This is kind of like a plug and chug type of question. One thing I note is that the answer choices have pi in them, so we're not going to have to actually use 3.14 in the calculation, which makes it a little bit easier. And here is our volume formula. So we're going to do 4/3 pi r cubed. And in this case, our radius is 3, so I'm going to put 3 cubed in right here. And so when we do the calculation in our calculator, we will see that the answer, if we just leave pi in the answer, is B, 36 pi. So now here is a practice example with surface area for a sphere. And let me give you a chance now to pause the video and try this question out. And whenever you're ready, we'll go over the answer. Okay, so just like the volume calculation, my hope is that this was pretty straightforward. And let me explain how to do this. So basically, we're going to pick the surface area formula, and we're going to just plug in 2 for r here. So we would do 4 pi r squared. And again, since r is 2, we're just going to do 2 squared. And if we do this in our calculator, and we also see that we don't have to use pi in the calculation because they left it in the answer choices, the answer is going to be 16 pi. So hopefully this makes sense. So now let's talk about right prisms. And some textbooks that I looked at didn't even mention right prisms, or at least I didn't see it in there, which is kind of interesting. So I'm not going to make too big of a deal out of right prisms, but I do want to look at one example here. And the formulas are on the formula sheet, so that's why I want to just cover this to cover our bases. And the formula here is the volume equals the area of the base times the height of the prism. That's for volume. And for surface area, it's the perimeter of the base times the height of the prism plus 2 times the area of the base. Now, I didn't really want to show this formula because it kind of gives away part of the strategy to get the question right, but I figured why not just give this to you to save you some time. So for this figure on screen, which I drew, and I know my drawing is pretty bad, but I couldn't find a good picture of this to use, so I just drew my own here. But what you'd want to see here, first of all, is that the base is a triangle. So you'd want to go to the formula sheet and pick out the formula for the area of the triangle, and that is half base times height. So again, I didn't really want to include this formula here because it kind of gives away a key part of the question, but I figured why not? I'll just put this here to save you time since we're just practicing. And let me just read this number here because this is kind of a weird number, but this side of the triangle, it's 11.402. So this number here is 11.402 for this side of the triangle. And don't worry about the units right now. Please disregard the units because we're just practicing right now. So just disregard the units. Let me give you a chance now to try to calculate both the volume and the surface area for the right prism on screen. So let me give you a chance to pause the video and try this out now. Okay, so let's start off by calculating the volume. So the formula for the volume, it's the area of the base times the height of the prism. So let's start by calculating the area of the base. So as I said, we see here that the base is a triangle. So that's really important to note here. So to get the area of the base, we're going to calculate the area of the triangle. And the formula is half times base times height. So that's going to be half times 7 times 9. And when I do that in my calculator, I get 31.5. So we now know that the area of the base is 31.5. So I'm going to plug this into my formula here for volume. So I have volume equals 31.5 times the height of the prism. Now the height of the prism is this 20 right here. So that's going to be times 20. So 31.5 times 20 is 630. So the volume of the right prism here is 630. Now let's do the calculation for the surface area. So for surface area, we want to do the perimeter of the base. So what is the perimeter of the base here? Well, to get that, we want to again look at our base, which is the triangle, and we want to add up all of the sides. So I'm going to do 9 plus 7 plus 11.402. And I know that's kind of an odd number, but this is the example that I came up with here. And I know the numbers are kind of odd, but if we add this up, we see that the perimeter is 27.402. 27.402. So that's our perimeter. So when we do our surface area calculation, what we're really going to do is 27.402 times the height of the prism, which again is 20. So times 20 plus 2 times the area of the base. Now, what is the area of the base? Well, the area of the base is this 31.5. So we'll do times 31.5. And when we do this in our calculator, we get 611.04. And what the heck, let's just call it 611. So the surface area is 611, the volume is 630. And if you want to see another example of how to do right prisms, I'm going to put a link down below to Light and Salt Learning. Kate from Light and Salt Learning does a really good job with showing another example of how to do the volume of a right prism. And she has a lot of really good videos, so if there's ever anything on the GED test that you're confused about, chances are she has a video on it on her channel. She has a lot of helpful content, so again, I'll put a link to that video down below if you want to see another example of this. And just in general, her channel is great to watch for the GED.